Hello there, everyone. Good to see you once again after a while. Sorry for not dropping videos quite oftenly like before. And now we are going to discuss with a new concept. We have just finished the three-dimensional geometry of 11th class, right? So today we are going to discuss a new concept which will be discussed in general. So that will be probability. This chapter we will not discuss it with regards to any particular class, but we will be discussing this chapter with regards to ninth and 10th class concepts. Okay, so we will be discussing a mixture of concepts that are involved in ninth and 10th class. As you all know that probability of ninth class is very basic, so I will be starting with all the basics of probability, and then we will discuss one particular problem in this series of videos. So today let's first start with the probability. What is probability? It's the percentage, it's the ratio, it's the, we can say in a normal language that it's chance, like what thing can happen by chance. For example, when we say it might rain today, so there is chance of raining, and there is also not a chance of rain. So that's why this is actually the concept of probability. This was very informal and layman example. So in mathematics, if some events are occurring, for example 1 2 3 4 5 events are occurring, and you have to find the probability of one particular event. So the formula of probability is always equal to number of favorable outcomes upon total number of outcomes. Okay, so this is basically the formula. So when an event is occurring, of course that event will be dealing with some of the outcomes, so you have to find out the number of favorable outcomes first. For example, in this case, in total there are 5 outcomes, but the number of favorable outcomes we have to only deal with one, so it will be 1 upon 5. This is how you can find the probability of any event. Okay, now one more thing, probability can never be more than 1. It's always between 0 and 1. It can't be negative, it's always between 0 and 1. It can never be greater than 1. So just keep this thing in mind while attempting sums of probability. Apart from that, a very useful formula, for example, if the probability of happening of an event is P of E, and the probability of not happening of that event is P dash E, so then there is a formula which constitutes P of E plus P dash E. This is always equal to 1. Or in other words, you can say the probability of happening of an event is equal to 1 minus the probability of not happening of that event. So this is the basic formulas that you can keep in your mind before starting with the probability. So in ninth class, most of the sums are very basic, like cards and coins and dice. And in ninth class you have dealt with one coin, few cards and one dice problem, but in today's video we are particularly going to discuss about two dice problem, right? So let's move to that. So by taking some of the examples you will be able to know that how two dice problems work. When I state two dice problem, what does I mean? I mean that we have thrown two dice, right? Of course, on one dice there are 6 numbers, and on second dice there are 6 numbers. So the sums like this come like we have thrown two dice, and find the probability that sum of the two numbers appearing on the top of dice is 8. Like, of course, on the first dice it can be some number, on the second dice it can be some number. So there are some of the outcomes, right? So we have to see, we have to put out those outcomes in which the sum of numbers on the both of the faces of dice, the top faces, must be 8. For this, firstly we have to write all the possible outcomes. So in that way we will be able to find out the number of total outcomes and also the number of favorable outcomes. So what will we do? We have to write outcomes, and most of the students find it difficult. They used to cram these outcomes, but you don't have to cram at all. What will we do? For example, we have thrown two dice. Be more practical in your head. On the first dice, it's 1 on the top of it. On the second dice, it's also 1. This comprises of one outcome, right? On the first dice, it's 1, and on the second dice, it's 2. Second outcome. On the first dice, it's 1, and on the second, it can be 3. On the first dice, it can be 1, on the second, it can be 4. On the first, again consider 1, and on the second consider 5. On the first dice, again 1, on the second 6. Now we cannot choose any number more than 6, of course it's a dice. In this way we have written 6 outcomes, but no, these are not all the outcomes, because we have not varied the number that is appearing on the face of first dice. So now it's time to vary the number appearing on top face of first dice. So what will we do? On the first dice, they can be 2, on the second it can be 1. On the first 2, on the second 2 as well, then 2, on the second 3, on the first 2, then 4, 2, 5, 2, 6. Now we have written 2. Of course, then again increase the number on the first dice. It can be 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. Of course, for 4, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. Then 5, 1, then 5, 2, then 5, 3, then 5, 4, then 5, 5, and then 5, 6. On the first it can be 6, on the second it can be 1, on the first it can be 6, then 2, 6, then 3, 6, then 4, 6, then 5, and 6, then 6. So these are the total outcomes, and if you will count how many of these are there, 6, 6, it means 36. So in total, in 2 dice problem, the total number of outcomes will always be equal to 36. This is how you have to write all the outcomes before applying the formula of probability. And now let's move to the cases that we have to discuss, like what type of sums can be there. Now we have our first example, right? What's the probability that the sum of two numbers appearing on the top of dice is 8? So what's the problem? That is, sum is 8. Sum of what? The two numbers that are appearing on the face. So we have to find out the outcomes on which by adding both of the numbers we are getting 8. So you can see 6, 2, then 3, 5, 6, 2, 3, 5, then 4, 4, 5 and 3, then 6 and 2. Apart from that, there are no other outcomes on which by adding both of the numbers we are getting 8. So how many of these outcomes? These are 5. Probability means number of favorable outcomes on the top, and in the denominator total number of outcomes, that is 36. So our probability is 5 upon 36. How easy it was, right? Then the sum must be 13. Now you can see the largest number, the largest pair is 6 and 6. By adding 6 and 6 we are getting 12. So there is no case, there is no chance that we can get 13. So the probability of an impossible event is always 0. Kindly note this down as well, that an event which cannot occur with the given conditions, of course if there would have been 3 dice, then it could be possible to find out the outcome in which the sum is more than 12, that is 13. But in this case, in the given condition, we have no pair in which the sum is 13. So yes, that's the probability will be 0. In the third case, it's the sum can be less than equal to 12. So the sum can be less than equal to 12. Of course, equal to 12 means this outcome, and all of these outcomes are constituting sum less than 12, right? 11 11 10 10 10, then 9 9 9 9, and in this way 2. So these are all less than 12, and equal to 12 is also permissible. So total number of favorable outcomes are 36, and what is the total number of outcomes? That is again 36. So the probability is 1. In this way you can solve the problems including two dice. Like when we throw two dice, so there can be sums, like more sums like this, like two dice are thrown, find the probability of number less than 5, the sum should be less than 5. So these kind of sums can be there, right? Now sometimes it is written that a die is thrown twice. Now let me tell you, if two dice are thrown at once and a die is thrown twice, it means the same. The outcomes will be same, the method will be same, everything will be same. So for example, take this example, a die is thrown twice. What's the probability that 5 will not come up either time? It means there should be no 5 on both of the faces. Okay, on any one of the faces 5 will not come up either time. Like on both of the faces there should be no 5. So of course, excluding 5, excluding the outcome in which there are both 5, right? So this is the outcome which will be excluded, and the rest of the outcomes will be counted as our favorable outcomes, and total outcomes will be again 36. In the second part it's written that 5 will come up at least once. So there can be 5 once, at least once, at most it can be 2 as well. So 1 2 3 4 5 and 6. So and also 1 2 3 4 5 6. So 6 and 6 12, because in this row 5 is coming up at least once, and in this column 5 is coming up at least once. So total number of outcomes will be, of course, 6 plus 5, 11. 11 upon 36 will be our probability. So in this way you can find the probability of any condition under the statement of two dice thrown. In the next videos we'll be discussing about two coins problem as well as the cards problem, right? So it was all, and you can start trying the sums including probability, including the cases of two dice getting thrown simultaneously, right? So till then, have a good day, keep practicing, and don't forget to subscribe my channel in order to watch new videos like these, which will surely help you in getting good marks in your exams. Thanks for watching my video. See you in the next video. Have a good day.